Question 2. A particle moves at its displacement s meters from a point O after t seconds is given by s equals 4 cos of 2t. We want to show that this particle will perform simple harmonic motion. So if the displacement s is 4 cos of 2t, the amplitude is 4 and omega is 2. If we differentiate the displacement s, this gives velocity. So velocity is the sdt, and this is going to equal minus 8 sine of 2t. So the 2 multiplies with the 4 to give 8. When you differentiate a cos, it gives a minus sine. So velocity is minus 8 sine of 2t. Acceleration then is the rate of change of velocity. So a equals dv dt, or that's the same as d2s dt squared. If you multiply the 2 by the 8, that gives us 16. If you differentiate a sine of 2t, it becomes a cos of 2t. So the acceleration a equals minus 16 times the cos of 2t. Now omega is 2, that means omega squared is 4. If we factorize out a minus 4, a equals minus 4 on, and then we're left with 4 cos of 2t, which is the original displacement s. So here the acceleration a does equal minus 4 times s. And since the acceleration does equal minus a constant times the displacement, this means the particle does execute simple harmonic motion. Part 2, we want to know what the greatest distance between the particle and the point O is. Now the greatest distance is the amplitude A, and the amplitude A is 4 meters. In part 3, we want to know how long it will take to go from a point where its velocity is 0 to a point 2.5 meters from O. Now again, s equals 4 cos of 2t. So we want to find out what the time is when the displacement from O is 2.5. So s is 2.5. So 2.5 is 4 cos of 2t. If we divide 2.5 by 4, it gives 0.625, and this equals the cos of 2t. Inverse cos of 0.625 equals 2t. When your calculator is in radiant mode, so this must be in radiant mode, the inverse cos of 0.625 for the first time is 0.89566. There is an infinite amount of other values, but for the first time this works at a 0.89566 is 2t, and then dividing by 2, this means the time is 0.45 seconds.